So, when I first looked at number 20, when I was putting together everything to make the review videos, I thought it was kind of a simple question. Not saying it's too hard, but then, when I read it just before I started making the videos, I was like, oh man, wait a minute. This video may be kind of long, but I'm going to explain to you in great detail so you guys can have it down packed in your head, write it down, practice, make sure you're comfortable with everything. Feel me? So it says, find the area under the standard normal curve that lies outside. And I want to I'm going to highlight that. Lies outside the interval between z equals to negative 2.3 and z equals to negative 0.8. So what I'm going to do is I'm going to draw my bell-shaped curve, my standard normal curve. Look how beautiful this curve is. When I say standard normal curve, your mean is 0. The mean is the middle value, and the standard deviation is 1. So that's the units. I'm going to move to the right, 2, 3. They should be evenly spaced apart, but if you know me, you know I'm not good when it comes to things like that. Negative 1, negative 2, negative 3. Okay. And by the way, I'm not going to do this for every curve. You can choose to put the standard deviation if you prefer. So, we have negative 2.3, which I'm going to place right here because negative 2.3 is between negative 2 and negative 3, closer to negative 2. Z equals to negative 2.3. And we have z equals to negative 0.8, which is between 0 and negative 1, but closer to negative 1. I'll put that right here. Now, if you notice what it says we want to find the area under the curve that lies outside the interval, right? So let's find the area under the curve that lies outside the interval of negative 2.3 and 0.8. Which means with z equals to negative 2.3, I'm going to shade that to the left. And for z equals to negative 0.8, I'm going to shade that to the right. So this is what we call a two-tailed shading. In a sense, a two-way shading. And if you know me, I have to get in all the curve. I can't leave too many spots left uncolored in. Don't be like me. Okay. So now what we're going to do is, right, we want to find the probabilities. We want to find the areas of those z-scores. So let's go ahead and find the area or the probability that z equals to negative 2.3. And let's find a probability that z equals to negative 0.8. And we're going to use our standard normal distribution table. Whenever it loads, because I thought I had it loaded already. Okay, so our z-scores are both negative. So we're going to go to the negative side of our standard normal distribution table. The first one I want to find is z equals to negative 2.3 or negative 2.30. So what I'm going to do is right here, right? I'm going to write the z-score right here. Z equals to negative 2.30. And for those who have trouble reading the z-score table, I'm going to briefly go over it. To find that probability or that area, take the first two numbers, which is negative 2.3. Start with the z right here and travel down to negative 2.3, which is right here. Look at the third number. The third number will help you focus on the scale at the top. Since it ends with a 0, you're going to move over until you reach that value. And the z-score for negative 2.30 is going to be 0.0107. That's the area under the curve. Well, rather, that's the probability for that z-score. All right, make sure you have this down. I'm going to now clear, and I'm going to report that back onto my whiteboard, which, by the way, is called OneNote, if anybody likes Microsoft. What I'm going to do is I am going to now do the same thing, but I'm going to find the probability for z equals to negative 0.8. So start at z, go down to negative 0.8, which is right here. The number after that is going to be 0. Let's zoom out a little bit. So we're going to go 1 over to the right, and that is 0.2119. So that's going to be 0.2119. Okay. I'm going to go back to the standard normal distribution table, right? I want you to look at the pictures down here. If you notice, the area in this picture is shaded to the left. I'm going to go to the positive z-scores. And once again, the area is shaded to the left, which means all the probabilities on the z-score table, once again, is shaded to the left. For this section right here, that is shaded to the left, which means the probability that z, in this case, will be less than negative 2.3 is going to equal to 0.0107. That's fine. But in this case, when it comes to this shading, this is shaded to the right. And we can call that the probability that z is greater than negative 0.8. Because that is shaded to the right and all probabilities on your z-score table is shaded to the left, once you find the probability on your z-score table, you can subtract that probability from 1. So it's going to be 1 minus 0.2119. That goes back to the complement rule of probability. And that's going to equal to 0.7881. Now, to wrap this up, because I have a two-directional shading, once I find the probabilities for each of those, I can add those together, and that will be the final answer. Majority of my curve is shaded, so that means my probability, my area should be great. It should be large. So we can add the 0.0107 with the 0.7881. And when I add those together in the calculator, although I move kind of slow doing it because, you know, I'm not technological savvy like you guys are, that's going to equal to 0.7988. Could have kind of did that in my head. I think so. Nah, I like this way. And that's going to be the area under the curve that is shaded. All right, guys. Hope that made sense to you. Once again, this is a two-directional shading. It's not shaded in between. The process is a little bit different. In the next few videos, we're gonna go over normal distribution. Ultra introduce the central limit theorem in this review videos, so you know, a whole bunch of fun stuff. I can't wait. Can you wait? No, you can't. All right, guys. See you soon.